Now that you're done with your pressure lab, air pressure lab, and your convection lab, wanted to go through some notes about how air pressure affects weather specifically. It's one thing to understand air pressure. The harder part is now applying it to weather. So right now you should have a copy of this document pulled up in your Google Drive, and following along, I should go in order through these notes, and you can follow along with me. First, what is air pressure? What is pressure? Pressure is the ability to push on an object. In this example, I have a submarine. Submarines have the ability to only go so far down in the water because once they get so low, there's so much water on top of them pushing down on them that it would actually crush the submarine. Another example that I thought of was diving deep in a pool. The deeper you go, the more you feel pressure pushing on your ears. So that's a really good real-life example that you've probably experienced. Air pressure is the force exerted by molecules in the atmosphere due to gravity and temperature. This tends to be where affected by three different things: temperature, altitude, and humidity. So far, I think we've done a really nice job of relating temperature to pressure, realizing that in general, the hotter the air, the more spaced out those particles are and the lower the pressure. And the colder the air, the more packed those particles are together, the more dense they are, which affects their pressure. Two other variables that play into pressure is altitude. Again, we've also talked about this one, where the higher up you go in the atmosphere, the less particles there are above you pushing down on you, and the less dense the air, meaning higher elevation equals lower pressure, lower elevation equals higher pressure. The third element is humidity. This is one we have not talked very much about, and humidity tends to affect pressure in that the higher the amount of moisture in the air, the higher the humidity, the lower the pressure. And this makes sense because humid air tends to be warmer and also cause that air to rise, make clouds, and cause precipitation. So low pressure and humidity tend to go hand in hand. This image right here shows how a traditional barometer works. Barometers measure air pressure. They used to use mercury, and mercury would rise when the air pressure pushed on it. So we would see inches of mercury going up or inches of mercury going down as the outside air pressure changes. The readings, the measurements that we use for barometers is either inches of mercury, because mercury used to be used, it isn't anymore due to safety, or millibars, and that has to do with the measurement of the height of the liquid inside of the barometer. When air pressure increases, so we get a high pressure day, the air, as you see in this one right here, the air pushes harder, which pushes up the liquid higher, causing the barometer reading to go up. The barometer reading goes down when there's a low pressure day and there's less particles pushing on it. So we say the pressure falls or the pressure drops. What does this help us with weather? How does this affect what we can understand about weather? Well, if we see the pressure starting to drop, we can assume that there is bad weather coming, because with pressure falling equals air rising, creating clouds and causing storms. When the pressure goes up and we see the barometer rising, we know that the air is more dense and it's sinking, pushing out the clouds and causing a blue sky nice day. So we can pay attention to this barometer to get an idea of what the weather is that's approaching. This is an image that I recommend you using when you draw in your notes for high pressure and low pressure. Low pressure air rises because it's less dense, creates clouds and precipitation, while high pressure sinks, pushes out the clouds because it's more dense, and it creates blue sky days. So I'd recommend maybe pausing your screen right now and making sure to get this image drawn in your notes. Kind of a 3D model that I like here is is this picture, because what you've been looking at is kind of two-dimensional. This adds another layer to it. So you picture the United States. You need to picture that air rising high above it, well, in this case sinking, in that clockwise fashion in a high-pressure system. And in a low-pressure system, again, that 3D model of that air circling, going upward in that low-pressure system. So what type of weather would we associate with high pressure? High pressure typically means clear skies, sunny days, dry weather, high day and low night temperatures, calm weather, dew, fog, and mist in the morning. So picture this when you think of a high pressure day. Perfect summer day. Low pressure days are associated with cloudy skies, low levels of sunshine, wet weather, temperatures that are mild for that time of the year, windy conditions, and changing weather. Air is typically moving towards a low pressure system from a high pressure system. So picture low pressure, bad weather, storms, precipitation. In the convection lab specifically, we noticed that air or fluids always move from high pressure to low pressure systems. Again, this is because low pressure air rises, creating an empty space below it, and that high pressure air comes in to fill it. So this is why air or fluids always move from high pressure to low pressure. This is what causes wind. Wind is the movement of high to low pressure air. The stronger the difference in pressure, the stronger the wind. This graph or chart shows us the barometer reading for the United States. High pressure, low pressure. Air in this case is moving outward from the high pressure towards the low pressure. If I look at the millibar reading here, I look at my numbers, and each of these isobars, these lines, indicate a change in pressure. So as we work our way out from the high pressure and towards the low pressure, each time we pass a new millibar, we know there's a change in pressure. I have my lowest readings here at the center of the low pressure system, and then my highest readings over here at the center of the high pressure system. Here's a little bit more complicated of a chart. I should be able to, at this point, look at a chart and be able to explain things like, where is the high pressure system, which in this case would be over here at letter D, and where's the low pressure system? In this case, it's over one of the lower pressures is at letter A. And we know that by looking at our readings and kind of comparing them to the other ones on the chart. What I'd like you to do right now is to practice identifying this by looking at your screen and pausing it with your partner and having a brief conversation right now. Can you look at this map and identify the high pressure systems? And can you identify the low pressure system? So go ahead and pause your screen and do that real quick just for practice. Now that you've had a chance to do that, and I hope you did, the high pressure systems, letter F would be an example of a high pressure system. If we look at our reading, it's a little higher. Letter E would also be a high pressure system. Letter K would clearly be a low pressure system, as that's one of our lowest numbers on the chart. Letter B would also be a little bit lower of a pressure. Now something to note here, the stronger the difference in the number between these isobars, the stronger the winds. Another map, now this is another layer to it, we have not only high and low pressure systems, we also have fronts located on this map. We're going to look more at fronts coming up in the next couple lessons here. So this is one that we'll pay attention to later. But what I'd like you to be able to do at this point is look at this map and say, oh, high pressure here, good weather, blue skies. Low pressure here, bad weather, most likely storms. That's a pretty basic skill that you should be able to interpret with looking at weather maps. What does this cause? This causes wind. Wind always moves from high to low pressure. That's a basic, and that's another big concept that you should be able to see at this point. Just want to pull up today's wind map and make one last observation before we wrap up. Knowing that wind moves from high to low pressure, I can look at this map right now and make some pretty clear statements about where the high and low pressure systems are. Right here, we have low winds, and the air is moving away from it, so that's pretty obviously a high pressure system. Right here, all the air is moving towards it, and it's circling around it in a counterclockwise fashion. Clearly a low pressure system. Again right here, all the air is moving around in this center point, moving towards it, another low pressure system. I know that today, in this location and this location, there's storms. I know that here, it's blue sky, beautiful sunny days. That's also true over here. In case you missed any notes, here are all of the notes filled out for you, so you can double check to make sure that you got them right and add to any ones that you missed. Thanks for watching.